In our last journey together, we explored the ancient oceans. These were bustling worlds, teeming with strange and wonderful life. The seas were the cradle of existence for billions of years. Complex animals first appeared there during a time we call the Cambrian explosion. Life was an experiment. Creatures with bizarre body plans swam, crawled, and hunted in the water. We saw the rise of trilobites, with their hard shells and segmented bodies. They were some of the most successful animals of their time. We also met fearsome predators like the Anomalocaris, a giant shrimp-like creature with grasping claws. It was a very different world from ours. The oceans were a vibrant but crowded place. Competition for food and space was intense. Every creature had to find its own way to survive. Some developed armor for protection. Others evolved speed to escape their hunters. The basic blueprints for many animal groups we know today were being drawn up in those ancient waters. Vertebrates, animals with backbones, made their first appearance. These were our own distant ancestors. They started as small, jawless fish, filtering food from the water. They were not the rulers of the sea, not yet. They were just trying to survive like everyone else. Imagine a planet where all the continents were barren rock and dust. There were no trees, no grasses, no flowers. The land was silent. The only sounds were the wind and the rain. The sun beat down on an empty landscape. But below the waves, life was a chaotic and beautiful dance. Coral reefs were beginning to form, creating new homes for thousands of species. Giant sea scorpions, some as long as a person, patrolled the sea floor. The oceans held all the drama of life. The land, by comparison, was a desolate and empty stage, waiting for its first actors to arrive. This watery world set the stage for one of the greatest stories in the history of life. The move from water to land was a monumental step. It was not easy. It required a whole new set of tools. Animals would need a way to breathe air instead of water. They would need a way to support their bodies without the buoyancy of the sea. And they would need a way to find food in this new, harsh environment. The story of how life conquered the continents is a story of incredible transformation. It is a story of pioneers, adventurers who dared to leave the only world they had ever known. Our story picks up in a time known as the late Silurian and Devonian periods. This was roughly 420 to 360 million years ago. The Earth looked very different then. The continents were arranged in a new way. There were two major supercontinents, Gondwana and Euramerica. The climate was generally warm and stable. This was a time of great change, both in the sea and, for the first time, on the land. The stage was being set for a great leap. Life was about to take its first tentative steps out of the water. This was not a single event, but a long process. It happened over millions of years. Why would any creature want to leave the ocean? The water provided everything life needed. It offered food, shelter, and a stable environment. But the oceans were also becoming more dangerous. Big predatory fish were evolving. They were fast, and they had powerful jaws. For smaller animals, the sea was a risky place to live. The shallow coastal areas and freshwater rivers might have offered a refuge. These areas were less crowded with large predators. They were a potential escape route. It was in these shallows that the first steps towards a new life would be taken. The land also offered new opportunities. There was unclaimed territory. There were no predators to worry about, at least not at first. There was abundant sunlight. If a creature could figure out how to survive on land, it would have a whole new world to itself. This was a powerful incentive. Evolution often pushes life into new empty spaces. The empty continents were the biggest empty space of all. The move to land was not just about it was also about seizing a brand new opportunity to thrive and multiply in a world untouched by animal life. The sea is set to be shallow water, that acted as a bridge between these two worlds. This is the transition zone. This is where the drama will unfold. The creatures that lived here had to be adaptable. They had to be able to handle changing water levels and changing salt content. These pressures would forge the first pioneers. They would shape the bodies and behaviors of the animals that were about to make history by leaving the water behind forever. Before any animal could live on land, something else had to get there first. Animals need to eat. On land, there was nothing to eat but rock and dust. The first pioneers were not animals, but plants. They began a process that would completely transform the planet. They were the true trailblazers. For millions of years, the land was sterile, but slowly, green began to creep out of the water. Simple algae and lichens might have been the very first to cling to wet rocks near the shore. But the real revolution came with the evolution of the first true land plants. One of the earliest and most important of these was a small plant called Cooksonia. It lived around 425 million years ago. It was not very impressive to look at. It was just a few centimeters tall. It had no leaves, no flowers, and no true roots. It was just a simple branching green stalk. At the tip of each stalk was a small capsule that contained spores. These spores could be carried by the wind, allowing the plant to spread across the land. Cooksonia was a survivor. It had a waxy outer layer called a cuticle to keep from drying out. It also had simple tubes inside its stem to carry water. These first plants were revolutionary. They started to create soil for the very first time. As they died and decomposed, their organic matter mixed with the rock and dust. This created a thin layer of nutrient-rich soil. This soil could hold water. It provided a place for new plants to grow. The greening of the continents had begun. These early plants were tied to wet, swampy areas. They needed water to reproduce, but they were a critical first step. They were creating a new habitat. They were turning the barren land into a place where other forms of life could eventually survive. The impact of these first plants went far beyond just creating soil. As they spread, they began to change the atmosphere itself. Plants breathe in carbon dioxide and breathe out oxygen. This process is called photosynthesis. Before land plants, the amount of oxygen in the atmosphere was much lower than it is today. The spread of plants across the continents began to pump huge amounts of oxygen into the air. This had a profound effect on the climate and on the future evolution of animal life. Animals, especially large and active ones, need a lot of oxygen. The first plants were terraforming the planet. With plants establishing a foothold, the land was no longer completely barren. There was now a food source. The first animals to follow the plants onto land were not our ancestors, the vertebrates. They were the arthropods. This group includes insects, spiders, scorpions, and millipedes. They already had some advantages. They had a hard external skeleton, an exoskeleton. This provided support for their bodies outside of the water. It also helped prevent them from drying out. They were pre-adapted for the challenges of life on land in a way that soft-bodied creatures were not. Among the very first known land animals was a millipede-like creature called Pneumodesmus. A fossil of this creature was found in Scotland. It dates back to about 428 million years ago. What makes this fossil so special is that it has tiny holes on its body. These holes are called spiracles. They are openings to a system of breathing tubes. This is clear evidence that Pneumodesmus was breathing air. It was a true land dweller. It probably fed on the decaying plant matter that was now available. It was a humble pioneer, scuttling through the low green vegetation. Other arthropods soon followed. Early scorpions were among the first predators on land. They had already evolved their classic body shape in the oceans. They had claws to grab prey and a venomous tail for defense. Some of these early scorpions were amphibious. They could live both in water and on land. They likely hunted other arthropods like Pneumodesmus in the coastal swamps. Spiders and other insect-like creatures also made their way ashore during this time. For millions of years, the land was the kingdom of the bugs. They were the dominant form of animal life. This first wave of animal pioneers created a new ecosystem. There were herbivores, the plant eaters like the millipedes, and there were carnivores, the predators like the scorpions and spiders. A simple food web was beginning to form on land for the very first time. This was all happening while our own vertebrate ancestors were still swimming in the water. The arthropods had a huge head start. They diversified into an incredible array of forms. They were the undisputed rulers of this new green world. But that was about to change. The fish were coming. While the arthropods were busy conquering the land, big changes were happening back in the water. The Devonian period is often called the Age of Fishes. It was a time of incredible diversity and evolution for our vertebrate ancestors. Fish were developing new and powerful features. One of the most important was the evolution of jaws. Early fish were jawless. They could only filter feed or suck up small bits of food. Jaws were a game changer. They allowed fish to bite, to tear, and to become active predators. This led to an evolutionary arms race in the oceans. As fish became more powerful, they also evolved better ways to move. Fins became stronger and more complex. They allowed for greater speed and maneuverability. Skeletons made of bone rather than cartilage provided more strength and support. Fish like the giant Dunkleosteus, a massive armored fish with blade-like jaws, became the top predators of the sea. It was a dangerous time to be a small fish. This intense pressure in the water may have been one of the main reasons some fish began to explore the safer, shallower waters near the land. In these shallow, swampy environments, a new challenge arose. The water could be low in oxygen. Sometimes, these pools could even dry up. Fish that lived in these places needed a way to survive. A remarkable adaptation began to appear: lungs. Some fish developed simple sacs that connected to their throats. They could gulp air from the surface to supplement the oxygen they got from their gills. These were the first lungs. Many fish today, like lungfish, still have this ability. It was a crucial tool for surviving in the difficult transition zone between water and land. At the same time, another amazing change was happening. The fins of some fish were becoming different. The fins of most fish are delicate, supported by thin rays of bone. But in a group of fish called the lobe-finned fishes, something new was happening. Their fins were thick and fleshy like lobes. Inside these fins was a pattern of strong, sturdy bones. There was one large bone connected to the shoulder, followed by two smaller bones, and then a series of little bones at the end. This pattern should sound familiar. It is the same one bone, two bone, many bones pattern found in our own arms and legs. The stage was now perfectly set for a truly groundbreaking discovery. Scientists knew that there must have been a transitional creature, something that was part fish, part land animal. They predicted where they might find such a fossil. They needed to look in rocks of the right age, from about 375 million years ago, and they needed to look in rocks that were formed in the right environment, like a freshwater river delta. A team of paleontologists, including myself, went searching in the Canadian Arctic. After years of looking, we found exactly what we were looking for. We named it Tiktaalik. Tiktaalik is a perfect example of a transitional fossil. It blurs the line between fish and land animal. It had scales, fins and gills, just like a fish. But it also had features that were completely new. Its head was flat, like a crocodile's. Its eyes were on top of its skull, not on the sides. This suggests it was looking up, perhaps out of the water. Most importantly, Tiktaalik had a neck. It could move its head independently from its body. This is something fish cannot do. A neck is a vital piece of equipment for looking around and hunting on land. The most incredible feature of Tiktaalik was its fins. On the outside, they looked like sturdy fins, but when we looked at the skeleton inside, we were amazed. It had the one bone, two bone, many bones pattern. It had a shoulder, an elbow, and even a primitive wrist. This was a fin that could bend and support weight. It was a fin that could do a push-up. Tiktaalik was a fishapod, a creature that was part fish, part tetrapod, meaning four-limbed animal. It could probably prop itself up in the shallows and look around on the muddy banks of the river. Tiktaalik was not the only experiment in moving to land. Another important creature from this time is Ichthyostega. Found in Greenland, Ichthyostega was even more like a land animal. It had a stronger ribcage to support its organs out of the water. It had powerful, well-developed limbs with distinct toes. It was clearly capable of walking on land, though probably in a clumsy seal-like way. These animals, Tiktaalik and Ichthyostega, were not our direct ancestors, but they show us the incredible evolutionary journey that our distant relatives took. They show us how fins became feet. As animals like Tiktaalik were exploring the water's edge, the plants on land were undergoing their own revolution. The small, simple plants like Cooksonia gave way to much larger and more complex forms. This was the time when the first true forests appeared on Earth. These were not forests like we know today. There were no flowering trees or pine trees. These ancient forests were made of strange and alien-looking plants. They were dominated by giant club mosses, towering ferns, and primitive seed plants. Some of these trees could grow over 30 meters tall. One of the most important new plant adaptations was the evolution of true roots. Roots allowed plants to anchor themselves firmly in the ground. They could reach deep into the soil to find water and nutrients. This allowed plants to grow much taller and to live in drier areas, away from the immediate edge of the water. Another key innovation was wood. The evolution of strong woody tissue gave stems the support they needed to grow to great heights. This created a competition for sunlight, as plants grew taller and taller to avoid being shaded by their neighbors. These first forests had a massive impact on the planet. The deep root systems of these new trees broke up rock. This sped up the process of soil formation. It also changed the way rivers flowed, creating more stable riverbanks and clearer streams. The forests created a brand new complex habitat. They provided shade, moisture, and shelter. This new three-dimensional environment offered countless new places for animals to live. It was a world of deep leaf litter on the forest floor, complex trunks to climb, and a high canopy above. The rise of these forests also had a dramatic effect on the global climate. Trees pull enormous amounts of carbon dioxide out of the atmosphere to build their woody trunks. This massive removal of CO2 led to a period of global cooling. It also led to a huge increase in the amount of oxygen in the atmosphere, perhaps reaching levels even higher than today. This oxygen-rich air would fuel the evolution of the next wave of land animals. It would allow for larger bodies and more active lifestyles. The world was now ready for the age of giant amphibians and the first reptiles. The world at the end of the Devonian period was a completely transformed planet. What was once a barren, rocky landscape was now covered in green. The first forests stood tall, casting shadows over the land. The air was thick with oxygen. In the leaf litter and swamps, a vibrant ecosystem of arthropods thrived. And in the water and on the land, our own vertebrate cousins had made the great leap. Creatures like Ichthyostega were walking on sturdy legs. They were breathing air with lungs. They had successfully colonized a new world, a world of incredible opportunity. This transition from water to land was one of the most significant events in the history of life. It required a complete reinvention of the vertebrate body plan. Fins had to become limbs. Gills had to be supplemented with lungs. The skeleton had to be strengthened to fight gravity. The skin had to change to prevent drying out. The senses, like sight and hearing, had to adapt to work in air instead of water. This was not a simple process. It was a long and difficult journey, full of evolutionary experiments, dead ends, and stunning successes. The pioneers that made this journey had opened up a new frontier, but they were still tied to the water. These early tetrapods, like modern amphibians, likely had to return to the water to lay their eggs. Their skin was not yet waterproof enough to let them stray too far from the swamps and rivers. They were the first wave, but they were not yet the complete masters of the land. The next great innovation was still to come, the amniotic egg. An egg with its own protective shell and internal pond, which would finally sever the ties to the water for good. But that story is for another time. As the Devonian period came to a close, a new era was dawning. The basic tools for life on land were now in place. The stage was set for the next great burst of evolution. Animals would continue to adapt and specialize. They would get bigger, faster, and more powerful. The simple food webs of the early land ecosystems would become more complex. New predators and new prey would emerge. The silent, empty continents were now noisy and full of life. The adventure was just beginning. We have traveled an immense distance in our story so far. We have seen life emerge in the oceans. We have watched plants turn the continents green. And we have followed the first brave animals as they crawled onto the shore. We met the humble arthropods, the first pioneers, and we met our own distant cousins, the lobe-finned fishes that evolved into creatures like Tiktaalik and Ichthyostega. They took the incredible step of trading fins for feet and water for air. They opened up a whole new world of possibilities for vertebrate life. The next chapter in our story will be even more dramatic. We will see how these early land dwellers continued to evolve and diversify. The age of amphibians will give way to the rise of the reptiles. We will witness the evolution of the amniotic egg, the private pond that allowed animals to conquer the dry interiors of the continents. This innovation would set the stage for the dinosaurs, for the birds, and for mammals like us. The conquest of the land was far from over. In many ways, it was just getting started. In our next episode, we will explore this incredible diversification. We will see how jaws became more powerful and specialized. We will see how legs and bodies adapted for faster running and more efficient movement. The arms race between predator and prey, which began in the oceans, would now play out on a new global stage. The timid, swamp-bound pioneers we have met today will give rise to fearsome predators and giant herbivores. The world is about to become a much more dynamic and dangerous place. Thank you for joining me on this journey into our deep past. The story of life on Earth is written in the rocks beneath our feet and in the DNA inside every one of our cells. By understanding where we came from, we can better understand ourselves and the world around us. The story is far from over. I hope you will continue to explore with us as we uncover the next chapter in the epic tale of life. Stay curious and keep asking questions about your own inner fish.